In this concept video, we're going to be discussing some rules for fractions, adding, subtracting specifically. We're going to check out how it works in reverse and then talk about complex fractions briefly. This is really important stuff because when we're simplifying trigonometric expressions, you gotta have the basics down before you work with sine, cosine, tangent, and all the rest of them. So let's just begin with adding and subtracting with common denominators. So this would be a situation, we'll go maybe 1/4 plus 5 over 4. So here we have a common denominator. What we do is we're going to add the numerators together, and then we keep the denominator. When we simplify this, this is 6 over 4, and we need to further simplify if possible. We note that we have the same factor in the top and the bottom. That common factor is 2. So if we divide the numerator by 2 and the denominator by 2, we've got 3 over 2. This would be the simplified answer, and you want to simplify whenever you have that common factor. To see how this looks with algebra, you can think about it like A over C plus B over C. That's equal to A plus B over C. Remember that this first part is just like that right here. So we have a numerator, a different one, even if it's the same one, that's fine. You just add them together and then you keep the denominator. You do not add the denominators together. When we add or subtract fractions with unlike denominators, so now they're not going to be common, what we need to do is get a common denominator first. So let's think about this here with this example, 2/3 minus 7 over 4. What we need to have is we need to have a common denominator between the 3 and the 4, and what I'm allowed to do is I'm allowed to multiply this fraction by any fraction as long as it's 1. So for instance, I'm multiplying this left fraction by 4 over 4, which is 1. You can multiply anything, any number by 1, and you'll have the same value. You cannot multiply a fraction by something other than 1 and get the same value. It just doesn't work like that. The one on the right here, we're going to need to multiply that by 3 over 3. And this is getting a little busy, so I'm going to write that equal sign over here a little bit. The reason why we need to multiply this fraction by 4 and this one by 3 is because we'll then have a common denominator. So 4 times 2 is 8. 4 times 3 is 12. And if you think about it, 2/3 is the same as 8 over 12. This is 2 slices of a pizza divided into 3 slices. This is a pizza that's divided into 12 slices, but you got 8 of them. And if you eat each one of these, you're going to be eating the same amount. Now this one over here is going to be 21 in the numerator, 7 times 3 over 12. Now we have a common denominator. So we can do 8 minus 21, which should be negative 13 over 12. And you're going to see that negative sign written out front. This is definitely negative. We have something smaller than 1, 8 over 12 or 2/3. We're taking away something bigger than 1. So we're going to have a negative value as an answer. And I just want to make one little comment, and then you can multiply a fraction by some form of 1. And by some form of 1, I mean 3 over 3, 4 over 4, sine over sine. That's the big step here with the next few learning targets, but right now we're just doing this with numbers. So multiply a fraction by some form of 1 doesn't, maybe there should be multiplying a fraction by some form of 1 doesn't change its value. And that's what we want. We want to keep that value the same. Let's check out how this works in reverse. Let's try 2 plus 6 over 2. And we're wondering what that's equal to. Well, we know that if we do 2 plus 6, that's 8, and then divided by 2 is 4. So we can't change that value of 4. It has to remain 4. So if you're thinking to yourself, well, if I just did 2 over 2 and then added 6, that would be 7, and that wouldn't really work. So what I need to do is I need to take each numerator and divide it by the denominator. That's this part right here backwards. So if you have 1 plus 5 over 4, it's the same as 1 over 4 plus 5 over 4. So this would be, oh boy, 2 over 2 is 1, and then 6 over 2 is 3, and that's 4. And so we don't change the value as long as we write each numerator over that same denominator. So if you write this out, if you have a plus b over c, that's going to be the same as a over c plus b over c, where a, b, and c are integers, and c, of course, cannot be 0, or else we have a situation that is undefined. So keep in mind, if you tried to cancel the 2's out or made them 1 and then added 6, you wouldn't have the same value as 4. You cannot do that. Complex fractions are fairly easy. We've been working with them a little bit in class, and I will show you here what is going on with these complex fractions. Complex fraction just means a fraction within a fraction. So to simplify this, I'm still going to multiply this by 1. I'm going to choose to multiply the denominator by the reciprocal. So I'm going to multiply that by -8/3. And I must have the same value in the top and the bottom if I'm going to multiply the original expression just by 1. Now here's what's going to happen. Negative times a negative is a positive. 3 over 3 is 1. 8 over 8 is 1. We'll have 1 left underneath here. And so really all this is 4 over 5 times -8/3, or times the reciprocal. If we're doing this with a little bit of algebra, let me give you a over b and c over d. What we do here is we take the numerator fraction, the a over b, and you will end up multiplying by the reciprocal. And you can see here why that works. So that'll be d over c, which is just ad over bc. So we know that a positive times a negative is a negative. 4 times 8, 32. 5 times 3 is 15. And if you look here in the numerator, we got factors of 2, and then 5 and 3 aren't divisible by 2, so neither is 15.